Hey guys, hi everyone. Am I audible? Am I audible, guys? Am I visible? Yes, I think I'm visible. Don't know if I'm audible or not. That's the feedback that you guys will have to share with me. Hey guys, how are you all? It's the fresh beginning of the week. I hope all of you are doing fine. And just give me a quick feedback here, guys. How are you all? If you are able to hear me, if you are able to see me, just write yo in the chat box quickly. Awesome, awesome. Yo. My god, the entire Avengers team and the villain of the movie, Thanos, is also here in my class. I'm so happy. Rather, I'm so honored and privileged. Very nice. Hi, guys. How are you all? Okay. Okay, let me ask you guys a question in the beginning only. What else am I called apart from my name? Apart from my nickname, Suri, sir, what else do you guys know me by? Yes, Iron Man and other people, what do you all call me? Quick, quick, quick. I want to know how many people know my YouTube avatar. Okay, DD Matix remember, Hemlata remembers, I'm Rowdy remembers, Happy Mangal, Pranati remembers, Velpula. Arey wow, yaar. Awesome, awesome, awesome. Very nice, very nice, very nice. Awesome, awesome, awesome. So happy, so happy, so happy. Okay. And the dialogue also you guys remember Mogambo Kushua. Do you guys know who played the character of Mogambo in the movie Mr. India? Just a quick fun fact check. Do you guys know who played this character Mogambo? Do you guys know? Let me see if anybody knows the name of the actor. No, 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 I am not forgotten anyone. Yes, yes. Om, Tanuja, Sanjay. Everybody remembers that person, right? Such an awesome personality he used to be. You know what is so special today? What's so special today, guys? It's Mr. Amrish Puri's birthday. Yes. Today is Mugambo's birthday, guys. He unfortunately is not with us, as in he passed away in the year 2005 when I appeared for JEE examination and cracked this examination. But I just wanted to share this fun fact with you all that the real Mogambo, the actual Mogambo's birthday is today. So let's remember him, and I will obviously keep on reminding you all by his name. Okay, yes, I know. Awesome, awesome, awesome. It's not my birthday, it's Mogambo's birthday, the real Mogambo. I hope you all know that person. Okay, for those who do not know me yet, let's start, guys. This is me, your Suri sir. I am alumnus of IIT Bombay. Some tongue twister happening today. Okay, but humbly I'm known as Mogambo on this YouTube channel as well. Why? Because when you will crack this examination of JEE, Mogambo khush hoga. Yes, guys. Yes, Mogambo khush hoga when you guys will crack this examination. Thank you, Ritika. I'm glad that you guys are enjoying your sessions with me. I'm glad. I'm glad. Thank you so much for this, all of your attention and love. I'm happy to be here with you all, guys. Okay. Also, for people who are new on this platform, they must know what is the schedule that we follow for all my students who are going to target JEE 2022. That means people who are now moving to 11th standard. Okay. So every day at 7 p.m., like right now, we meet for theory discussion, and 8 p.m. on certain days, which are Tuesday, Friday, and Saturday. These 3 days we meet for MCQs. Okay. Apart from me, who tries to teach you all physics, you have your love sir. He teaches you chemistry, and your Arvind sir, he teaches you mathematics. Okay. So guys, please remember the timetable. Every day, 7 o'clock, you have to be on this awesome channel for this amazing journey that we are having. By the way, very recently, as in yesterday only, JEE channel has crossed 3 lakh subscribers, 6 lakh subscribers. We have now 600,000 subscribers. Thanks to all of you guys. Keep on spreading the word. Keep on telling your friends about this awesomeness. Okay, cool. Also, if you are new to the channel, then definitely subscribe to the channel right now. Be the part of this awesomeness so that you guys are preparing for your JEE examination along with 600,000 people more. Okay, 6 lakh students are already a part of this awesome channel. Okay, cool. So guys, let's start. If you guys are ready. Okay, it's not my birthday. It's not my birthday. Okay, it's real Mogambo's birthday, Mr. Amrish Puri's birthday. It is not my birthday. Okay, cool. Okay, thank you so much, Arun. So guys, today is the, I don't know, it's second or third session of work, energy and power, and today we are going to talk about the types of forces, and this is the second session. Yeah, it's about types of forces and kinetic and potential energy is the discussion that we are going to have. In the previous session, we talked about the other fundamental quantity of this chapter, which is work, and we understood that work could be done by a variable or a constant force. Okay, guys, awesome. Okay, Disha, happy birthday, happy birthday. Very good, Disha, happy birthday. Okay, guys, so let's start. And when we are going to talk about this session, we are going to speak about types of forces, and this is basically another classification of the forces. Before this, in laws of motion, we have already understood the forces as push and pull, contact and non-contact forces, right? So this is the third division, broad division that we are coming across, and those are conservative and non-conservative forces. Okay, it's going to be a very important classification of forces, guys. Why is it so? Because it will set the tone of the discussion of energy, especially the potential energy. In fact, I'll tell you guys the notion that we carry for potential energy from our 10th standard or 9th standard discussion. We only have seen potential energy as the potential energy which exists in gravitational field. Now, in next 2 years, you're going to see that potential energy is a much bigger and a very important physical quantity. Okay, in fact, it's going to come across different situations that you are going to meet potential energies in different chapter. You will obviously be meeting it again in gravitation, but later on you will meet the potential energy term in case of charges, in case of magnets as well. Okay, in fact, in this chapter also we'll speak about that in case of spring. Okay, first thing first, let's speak about the forces. So the types of forces, when we are categorizing, the first type of force is what we call as your conservative forces. Let me rather give you, instead of bookish definition, a very easy definition to remember. Okay, conservative forces, how you have to keep them in mind is that conservative forces are just like any other force which we have spoken about so far, and they are going to be applied on an object, and they will obviously try to make an object move. That means they will try to do whatever you studied in laws of motion, whatever we studied in the previous session about the work done. So conservative force will try to do the work, definitely. Now, when they will try to do the work, what will they do? They will rather not change the total energy of a system. Means what? Whenever conservative forces will work, they will not change the total mechanical energy of the system. Means what? If we talk about mechanical energy, which is kinetic plus potential energy, that summation will always remain constant whenever in the system a conservative force is working. Let's read the bookish definition as well for our better understanding. It says that if the work done by a force depends only on the initial and the final position of the body and not on the nature of the path or the length of the path followed, then the force is said to be conservative in nature. Okay, that means what? If you are going to take a body, or the conservative force is going to take a body from one point to another, it will do some work, but that work will not depend upon the path. It will rather depend upon the initial and the final position. And in this process, the total summation of kinetic plus potential energy will remain constant, or you can say the mechanical energy will remain constant. Okay, I should write it here only, that potential energy plus kinetic energy will remain a constant when your conservative forces will work. Now, what are the various conservative forces that we are going to come across in this journey? They are gravitational forces, electrostatic forces. Electrostatic means forces between two charges. Will come across magnetic forces, elastic force of a spring, normal force, we know this from laws of motion, and force of tension. Okay guys, so these are basically, okay, yes Frozen, I'm trying to teach something here instead of just looking at the chat box at the moment. Okay, I will look at the chat box also. Okay, don't worry. So guys, these are the forces which we have to remember. They are conservative forces, and as per the definition, say if I am going to take a body from position A to position B. So what is happening? A body is going to move from point A to point B. You can see that there are different paths which are being taken, and in those paths, say work done is W1, W2, and W3. So if the work is being done by your conservative force, then what will remain true? That all these works W1 equal to W2 equal to W3 will hold true. Okay, guys, I hope it's understandable. The work done by conservative force will not depend upon the path. It will only depend upon the initial and the final position. As long as they are same, the work done will come out to be same. So what are the examples? Have a look at these 6 forces. These are the forces that we are going to deal in 11th standard and 12th standard physics. Okay, awesome. Let's speak more about the conservative forces. So work done by a conservative force on a body is independent of the path taken between initial and the final position. That means what? If you want to take a body from A to B, there could be possibility of taking it from A to B directly, or you can take it from A to P to B. Okay. Now in this process, be it process number 1, be it process number 2, the body is moving effectively from point A to point B. So if the only force which is, or the forces which are working on the body, they are conservative in nature, we say that the body will still be acted upon by the same force, and the body will be undergoing the same amount of work done by the external force. In fact, if I change the path also, even if I take this random path also, still the work done will come out to be same. That means if I say that this is the path 1 from A to P to B, this is path 2, and this is path 3, then I'm saying that work done in path 1 is equal to work done in path 2 and work done in path 3. They are independent of the path. The work done is coming out to be equal. Okay, guys? Awesome. Awesome, awesome, awesome. Also, as I said, that work done by conservative force will never change the potential and the kinetic energy summation. It will always keep the total potential and the kinetic energy of the system constant, right? That means the value of potential energy plus kinetic energy will always remain a constant. So if say a body starts from point A, goes to P, then goes to B, and then comes back to A, means in the loop or in the round trip journey, A to P to B and to A again, we say that the body is starting from the same point where body had some total mechanical energy at A. So when the body has come back to that same point, the body will have the same amount of mechanical energy, which simply means that the work done by a conservative force in this round trip will always come out to be 0. Work done in a round trip will always come out to be 0. Remember that. In fact, if you want a small example over here, say if I take a body from here and I say that this point is A, I'm going to throw it upward and say the body will go to point B. In this journey, when the body is going up, the body is acted upon by a force that is mg, and say the displacement that it will cover between A and B is h. So you can see that the body is going up, the mg force is acting downward. So if I calculate the value of the work done in the process from A to B, that will come out to be mg into h into cos of 180 degree. So this work done comes out to be minus mgh, right? Now if the body will come down from B to A again by covering the same amount of displacement, but this time mg is acting downward and the displacement h is also downward, body is coming down. That means if I calculate work from B to A, that will be mg into h into cos of 0 degree, which will be plus mgh. So if you add these two works, what are you going to get? You're going to get the value of the net work done as minus mgh plus mgh equal to 0. Okay, that simply means what? It's the round trip. That's why the total work done came out to be 0. And mg is basically your gravitational force. So the net work done came out to be 0. Please remember this, a very important point, because the other type of force is going to contradict all these points, or rather it's going to be just opposite. Okay. Moving on. Now when we are going to speak about your non-conservative forces. So as far as the conservative forces were concerned, I said that conservative forces are the forces which are not going to change the potential plus kinetic energy, or you can say the total mechanical energy. But when we are going to speak about your non-conservative forces, their job is, when they are going to work, they are going to change the total mechanical energy of the system. That means potential energy plus kinetic energy of the system, when non-conservative forces will work, will not remain a constant. Let's read the definition also. It says that if the work done by a force depends not only on the initial and final position, not only on the initial and final position, but also on the nature of the path taken or followed between initial and final position, then the force is known as non-conservative in nature. Now look at the path, guys. This is path A to B. All of these are path A to B, but different amount of work, W1, W2, W3 are written, and they are not equal. If that happens, we say that the total potential plus kinetic energy is also not constant. Some amount of that energy will convert into some other form, and that is what we call as a non-conservative force. Examples for you to remember for next 2 years are all the types of frictional forces. Okay, guys? Okay, Marvel. That's good. Okay, guys. So what are your non-conservative forces? Friction, air resistance, and viscous force. All the forces which try to hinder the motion, they are basically your non-conservative forces, to keep it in mind. Okay. Let's understand them all more in detail. So what happens here? As I said, they are different. So when we are speaking about non-conservative forces, guys, in case of non-conservative forces, the work done by frictional force on a body is going to be dependent on the path taken by the body. That means what? Work done from A to B will not be equal to work done from A to B to B. The two work dones are not going to be same in this case. Okay, remember that. Also, when we speak about the work done by frictional force in a round trip, it will not come out to be 0. Please remember that. It will not be equal to 0. That means what? Say if you give a body some velocity from point A, you give it some velocity u from point A, and say it stopped at point B. So what happened here? From A to B, the friction force was working here. The body got displaced by S amount. So work done from A to B came out to be F into S into cos of 180 degree, which is basically minus Fs. Now when you bring the body back again by giving it some same velocity or same speed in the other direction, this is B and this is A. This time the displacement is going to be on the left side and the friction is going to be on the right side, which means work done from B to A will come out to be friction into displacement into cos of 180 again, because again the friction and the displacement are in the opposite direction, which means this is also minus Fs. So if you write the total work done A to B plus B to A, the round trip, that does not come out to be 0, rather it comes out to be minus 2 times of Fs, which is not equal to 0. So even when the body came back to the same point, the net work done does not come out to be 0. Please remember that. Okay, guys? Perfect. I don't think it's buffering. It's quite visible, guys. Yeah, I think I'm properly visible to all of you guys. Yeah, guys, am I audible and visible properly? Quick feedback, quick check. Perfect. JEE not postponed, guys. JEE is happening on the same timelines which are given, 18 to 23rd July. No postponement. Okay. Thank you, DD Matix. Thank you, everyone. Okay, guys. Why cos 180 is because every time when the body is moving, the friction is acting backward and the body is going forward. So the angle between force and displacement is 180 degree in both the cases. Okay, cool. Also, the work done by the friction force is not going to be fully recoverable, as some part of the work will be lost in the form of heat and sound. That is why the potential energy and kinetic energy of the system is not going to be a constant. That's what I'm saying. What will happen? Before the force will start working, the amount of potential plus kinetic energy will be reduced when the body is going to be acted upon by some non-conservative force. Okay, this is non-conservative force only. Okay, cool guys. Now let's speak about potential energy, which will be represented by alphabet capital U. Okay, remember, it will not be represented by capital P, because that you are going to use for power and pressure, and what you are going to use potential energy representation by, it is capital U. Okay, cool guys. So what exactly is potential energy? Let's understand the definition first. It is the energy which is possessed by the bodies exerting conservative forces on each other due to their configuration. It's a very important definition. Okay guys, whenever two conservative forces are, or other conservative forces are acting between two bodies, like a satellite and earth, like two charges, like two magnets. So whenever there are conservative forces acting between two bodies, they will store some energy, right? So whenever the two conservative forces are acting between two bodies, they will try to store some energy. The energy, that the form in which it will be stored, is what we call as the potential energy. Very easy example is to understand that whenever you are going to give some mechanical motion to a toy in the form of chabi, what you do, right? I don't remember what will you call it in English. If you take a kid's toy, which has usually that knob which you rotate, it basically has a spring inside, which we say, हिंदी में हम बोलते हैं चाबी भरना. तो अगर हम उस टॉय को चाबी देते हैं और छोड़ देते हैं, so what happens? The toy starts to move, right? So when you are basically doing your mechanical action, you are storing your own energy by making or working against the spring force, and that spring force is working and it is storing the potential energy. Okay, so please remember guys, potential energy, I'm speaking something very important, which is going to help you for the next 2 years a lot. The understanding of potential energy, or the existence of potential energy, comes only when there is a conservative force existing in the system. Okay, and we rather say that whatever is the work done by conservative force will be equal to the negative of the potential energy. This is what has been written here. Okay, for gravitational potential energy, though it is written here, that whenever we are going to speak about gravitational potential energy, I don't want you to just remember it as potential energy of gravity. Just these two are more important here for the understanding part. That work done by conservative force will be equal to the negative of the change in potential energy, or potential energy will be equal to negative of the work done by conservative force. I want you people to remember this more importantly. Okay, it is equal to the negative of the work done, negative of the work done by your conservative force in shifting a body from one point to another. Please remember that. Okay, it's the second lecture on this chapter. Okay, next is potential energy depends on the choice of your origin. Okay, sometimes we say that it is mgh energy. Right now, if you are measuring your own potential energy with respect to the floor that is below you, then your potential energy is very less. But say if you are on the second floor or on the third floor, then if you take the ground as the reference point, then your height is actually for the third floor or the second floor, whichever floor you are on. So your potential energy will accordingly change. So it depends upon the choice of origin or the reference point. Also, maybe the potential energy value will depend upon the reference point, but the change in potential energy will not depend upon the choice of origin. It will always remain the same, because the change in height will always matter whenever you are going to calculate the potential energy change. It will always be m into g into delta h. By what amount the height has changed, you'll be able to calculate the value of gravitational potential energy. Okay. Also, it is determined only by initial and final position and not on the path taken. Why? Because it is negative of the work done by conservative force, and work done by conservative force does not depend upon the path. Okay. Awesome. If you guys remember, in the previous session only we talked about the work done by the spring force, or we calculated the work which was done by external agent. So I want to give you guys a even interesting thing to remember here, that your change in potential energy will be equal to negative of the work done by the conservative force, but it's the same change in potential energy which will be equal to the work done by the external force. So whenever there are external forces working and only changing the potential energy, then whatever is the work which is done by external agent will get stored in the form of potential energy. So if you remember, in the previous session only, we considered an external force acting, and that external force was equal to the spring force. So when we calculated the work done, it came out to be half k x2 square minus x1 square. So if you put x1 value as 0 and x2 value as x, you remember that work done by external force in the previous session came out to be half k x2 square minus x1 square. Okay, so if I'm putting the value of x2 as x and x1 as 0, so it is coming out to be half k x square. And if we go by this, then what we are doing, we are calculating the value of change in potential energy, which is coming out to be half k x square. Okay, awesome. Please remember this part, it's very important for us to use when we are solving the problems. Okay. Also, the second type of energy, which we call as kinetic energy, you can represent it by capital K or just by writing KE. You remember this remains the same. It's the energy which is possessed by a body because of the motion of the body itself. Okay. So how you are going to calculate kinetic energy? It will be half mv square. I hope you guys remember that. Cool. Okay. Awesome. Yes, Sakshi Mishra, spring constant we found, we talked about last time. Yeah. We talked about the spring constant. The spring force is equal to minus of kx. This is what we defined last time only in the previous lecture. Okay. Cool. Now, awesome animation for all of you to see here. Look at what is happening here. When this block is moving, it has only kinetic, or rather it is talking about the total energy of the system. So see, when block is moving, only kinetic energy. Now what is happening? Spring is gaining the energy and block was losing the energy. Look at what happens when the block is pushing the spring. Block slows down, kinetic energy decreases and spring potential energy increased, and again opposite thing happened, right? Also look at this, high potential energy, kinetic energy, again potential energy, again kinetic energy. As this train is on the height, the potential energy is more, and when it is at low, kinetic energy is high. Getting it? This is what is happening. What we are saying, that the total mechanical energy of the system is conserved only when conservative forces are acting on the system. Please remember that. We are not saying that the total energy, law of conservation of energy is always valid, but total mechanical energy, when we speak about kinetic plus potential, will only remain constant when you have only conservative forces working. The point that I have been speaking from slide number 1. Okay, remember that. Okay, now the last thing before we go to the problem solving, we know that the work done by a conservative force is equal to the negative of the change in potential energy. Work done is equal to the negative of the change in potential energy. So if I write small work done, it will be small amount of change in potential energy. Work done can be written as F into dr. Change in potential energy is minus du. So the force can be calculated as minus du by dr. Okay, but remember, this is only valid for conservative force, because only conservative forces can change potential energy. Okay, if you want to calculate it, how you are going to calculate? By partial differentiation, minus du by dx I cap minus du by dy j cap and minus du by dz k cap. I will show you this with the help of example. This is something which people who are now in 11th standard might not be very comfortable about, but this is something that you will learn in mathematics and calculus in 12th standard. Okay, awesome. Cool. Okay guys, let's do some problems now. So guys, the first question is here. Let's see, what does it say? It says that a particle is acted upon by a conservative force, which is given here. The work done by the force when the particle moves from 0, 0 to minus 3, 4 will be given by what? Okay, So first let's calculate the value of displacement, which will be final minus initial position. So minus 3 minus 0, that means minus 3 I cap, and 4 minus 0, that is 4 J cap. Your force is given as 7 I cap minus 6 J cap. So the work done, which is nothing but dot product of force and displacement, will be multiplication of x component and multiplication of y component. Z component is any which way not there. Are you guys getting the answer? Okay, R is the position vector. Being noob, R is the position vector. Don't worry, I'm going to solve a question very soon on that. So this is 7 into minus 3 plus minus 6 into 4. So this comes out to be minus 21 and minus 24. So minus 21 minus 24 is going to be minus 45 joules. That means negative amount of work is being done. Okay. Yes, everyone, R in that derivation, this R is the position vector. Okay. R is position vector of the body. How much it is changing. Okay. Cool. So we got the answer as option C. Let's move on. Now this one, this says that the kinetic energy of the body of mass 3 kg and momentum 9 Newton second will be how much? So guys, when we talk about kinetic energy is given as half mv square. What I'm going to do, I'm going to multiply it by m and divide it by m. So I have m square v square by 2m, which is nothing but mv the square divided by 2m. That means kinetic energy m into v. What is momentum? M into v, right? So it becomes p square by 2m. Okay, let's calculate. P is given to us as 2 square, as in 2. So square that value is 2 into 2 divided by 2 and mass is 3. So what do we get the value as? No problem, Ashar. Answer comes out to be 2 by 3 joules. Getting it, guys? No problem, Ashar. Okay, so answer came out to be option B, guys. Very nice. Moving on to this one, similar to the previous question, two masses are given. They are moving with equal kinetic energies. We have to find out the ratio of their linear momentum. Okay, so we know that kinetic energy is given as p square by 2m. So we can rearrange to get p as under root of 2mk. You can rearrange it, right? So p is directly proportional to root m because k value is same for both the masses. So p1 by p2 will be equal to under root of m1 by m2, which is under root of 1 by 4, or simply 1:2. Got it, everyone? So the answer comes out to be option C. Very nice. Very, very nice. Awesome, guys. Awesome. Okay. Now, coming to that question which you guys were asking about, what exactly R is. So, guys, look at R vector here. What is given to us is potential energy, and we have to find out the force acting on the particle, which is at R vector, which is going to be I cap plus 2j cap plus 3k cap. So how we are going to find that? So we are going to find this by du by dr vector. Okay, actually you cannot put vector sign over there, but the overall vector will come, don't worry. Okay, so how we are going to solve this? It's minus du by dx I cap minus du by dy j cap and minus du by dz k cap. This is called as partial differentiation, which simply means we will take this equation. First we will differentiate it with respect to x, the entire equation, then with respect to y, then with respect to z. So when I'm going to differentiate with respect to x, okay, then what will happen? With respect to x, only this part will give me non-zero, everything else will come out to be 0, which means what? The differentiation of 2x square will come out to be 4x I cap, because differentiation of the rest of the part with respect to x will be 0. Okay. Similarly, now when I differentiate with respect to y, only this part will give me non-zero value, rest x and z will give me 0. So it will come out to be 9y square j cap. Okay. And when I'm going to differentiate with respect to z, what I'm going to get is differentiation of only 2z, which will come out to be 2 k cap. Rest everything will be 0. Okay, so this is 4x I cap, 9y square j cap, and minus 2 k cap. And now what you will do, you will basically put the value of x, y, and z as 1, 2, and 3 respectively. So minus 4 into 1 I cap, that's the point that we are now working with, minus 9 into 2 square j cap, and minus 2 k cap. So z component is constant. So minus 4 I cap, minus 4 nines are 36 j cap, minus 2 k cap. That's basically the force which is acting on the body at 1, 2, 3. Okay, understood, guys? What did we do? We differentiate 2x square plus 3y cube plus 2z first with respect to x, then with respect to y, then with respect to z. So with respect to x, only this part will give me non-zero value. With respect to y, only this part will give me non-zero value. And with respect to z, only third part will give me non-zero value. Okay, very nice, Narayana. That is awesome. Okay. Okay, now this one. What does this say? It says that a body of mass 2 kg slides down a curved track from point A to point B, and there is no friction present. That means only conservative force is acting. So you have to find out the speed when the body reaches B. So what we say that the total energy of the system will remain conserved. Energy at A will be equal to energy at B, which is potential plus kinetic. So if I consider this point as H equal to 0, so at A, the potential energy is mgh, but kinetic energy is 0, because here the velocity was 0. And here when the body is reaching, it will have some velocity Vb, but potential energy becomes 0 and kinetic energy becomes half m Vb square. So m and m gets cancelled. I have Vb square equal to 2gh. Okay, so that is 2 into 10 into height, which is equal to 1 meter. That comes out to be 20. That means Vb is equal to under root of 20. Though you can look at the option, it is 19.6. That means they want you to take the value of G as 9.8, but you don't have to, because you know that under root of 19.6 and under root of 19.6 and under root of 20, both of them are going to be nearly same. Okay, so the answer will come out to be option A, that is 4.43 meters per second. Okay, very nice. Okay, guys, cool. Now this one, this is basically work energy power plus projectile motion. Question says that you compress the spring by 5 centimeter, and after that you release it so that it gains some velocity v, the block, and it falls somewhere here by coming down by a height of 2 meters. It comes down by a height of 2 meters. So how much forward does the block go is what you have to find out. So guys, if I look at this velocity, I can say that half mv square gained by the block will be coming from the spring potential energy. First you compress the spring, you gave it some potential energy, after that you released, so spring would want to come back to the natural length. So in that process it will give away its potential energy. Whom it will give away the energy to? The block, and the block gains half mv square energy. 2 gets cancelled, v comes out to be k by m in under root into x. Okay, and if we talk about the time which is taken to come to the ground is under root 2h by g. So the total horizontal distance, let's call it r, not x, because it could be confusing. So r will be equal to v into t. V is already under root of k by m into x, and the time is under root of 2h by g. Okay, so k is 100, mass of the body is 0.1, x value is 5 by 100, that is 5 centimeter, and under root of 2 into 5, sorry, 2 into 2, that's the height, divided by g, that is 10. Okay, so this decimal goes, this becomes 1000. So this is 10 root 10 into 5 by 100 into 2 by root 10 is what I'm getting. Let me write it here. I have 10 root 10 into 5 by 100 into 2 by root 10. So root 10 and root 10 cancels. 10 and 5 cancels this 20 times. 10 cancels it. 2 cancels it. Effectively 1 is what I'm getting. So R value comes out to be 1 meter. Yes or no? Okay. What happened? DD Matix not getting the point. We compressed the body. So we gave the spring some potential energy. We compressed the spring, right? After that, we removed our hand. So spring would want to come back to the natural length. In this process, the energy which was stored in the spring will be given to the block. And now the block will start to move on the platform. Spring will entirely give the energy to the block, and block starts to move with some kinetic energy, which is half mv square. So we found the energy with which it is moving and eventually the velocity with which it comes off the platform, right? So it comes down by 2 meter and it is a projectile motion. So how much time it is going to take is under root 2h by g, and this is the velocity. Simplified it. Okay. Cool, guys. Okay. Now this one is your homework question. Okay, everyone. This is your homework question. You have to find out if the spring is getting compressed by 40 millimeter and the force which is acting is initially making the spring compressed by 1 millimeter. That means K is equal to F by X, which is given by 10 by 1 millimeter, 10 Newton by 1 millimeter. Find K from here, and you have the value of X given as 40 millimeter, X dash rather. So calculate the value of the work which is done in stretching the spring through 40 millimeter. Okay, so do solve this. Okay. No, Iron Man, the body is not moving with a constant velocity when the spring force is acting on it. The body, when it was in contact with the spring and spring was completely compressed, after that the spring makes the body move. But now when the spring comes to the natural length, by that time the body has gained the kinetic energy of half mv square. Now there is no conservative spring force acting on the body. So the body has gained the entire potential energy of the spring in the form of kinetic energy. Okay? Understood? Cool. So this is your homework question, everyone. And if people have missed the previous lecture and want to know how to cover up the topics which are done before this lecture, then all you have to do is go on the playlist, and on the playlist of the channel, what playlist do you have to look for? You have to look for the playlist that is 2022. That means for people who are moving to 11th standard and will appear for JEE in 2022. Okay, guys. So look for that playlist and you'll be able to go for all the sessions together. Okay. Also, guys, every day at 7 p.m. we have a live quiz which happens on Vedantu's platform, which is going by the name V Quiz. Awesomeness is that there are a lot of prize money on stake for us to win and a lot of cashback. Paytm cashback is there. All you have to do is go on your Play Store of mobile phone or App Store, download the app. If you already have the app, update it so that you can participate in this quiz. Okay. Also, guys, you know that on Vedantu we have a platform of Vedantu where we teach students, we coach students for JEE, NEET and other examinations. Okay. If you are interested, then we have an amazing subscription going on which we call as Vedantu Pro for specifically for JEE aspiring students. Also, there is a platform specifically as Vedantu Pro. For that, you have to follow this link available in the description box. When you will click there, you will be selecting your standard, your examination that you are going to prepare for with us. Okay, what you're going to get there: live interactive classes, assignments and notes, and unlimited test series with your own analysis of the performance. Let me give you the brief idea about what you should expect out of Vedantu Pro. Well, you will be getting 40,000 plus hours of live teaching. 20 plus teachers with immense experience are going to be your master teachers. Every week, every bi-weekly, you will have your tests and assignments of over 10,000 questions to appear for. You will have your options of choosing between English or Hindi type of batch. Continuous review of your area of improvements and your suggestions will be given to you. Also, unlimited access for micro and crash courses. Okay, this is how, by the way, the platform looks like. This is Pulkit are teaching. This is chat box where students can interact, and the Q&A panel where they ask the doubts. And this is how and where the teacher is explaining the concept. Okay, so guys, the subscription is available in monthly, quarterly, half yearly, or annual packages. Obviously, the costing differs if you go for a longer package. Okay, if you are interested in enrolling, and if you enroll now, you're going to get additional 15% discount. All you have to do, guys, go on this link and use the code SMPRO. Okay, when you use this code, you will get additional 15% discount. Okay, guys, I hope it's understandable to everyone. Also, if you are interested, you can be a part of our Telegram channel or Telegram group where we are giving up all the solutions of the assignments, study material, and daily updates of what is happening on this channel. Okay, link of that is also available in the description box, so do take that and join the Telegram group. Cool, guys. You get the playlist, Sahil, by going on the playlist tab. So videos and playlists are there on the channel itself. Okay, Sahil, playlist is in the YouTube channel itself. Cool. Chalo, guys, I hope you guys enjoyed studying this part with me. If you did, then definitely press the like button over there. It's there, right there. Okay, and share with your friends. Let them also study with you. And if you have not, then do subscribe to the channel right now and press the bell icon so that whenever your Mogambo comes live, you get the information, you get the notification. So guys, with a promise to all my 2020, 2021 and 2022 aspirants that your learning won't stop, I will take your leave and I will see you very soon to continue this journey. Stay tuned, keep studying, keep enjoying physics. More importantly, stay safe. Bye-bye.